All right, so the last video was a study guide on the topics you should study. We're going to start going through some of these problems. So when we went through absolute value on page 144, what was absolute value? 140 what? 6? Okay, so I want to give you some other types of problems. So the first one is, sorry, that's a positive 3. Okay, so I might give something like this and ask you to simplify. Okay, simplify. So pause the recording, see if you can do that now. Let's get started. How might I begin to do this? Let's start with, how about Sarah?
What I do first is I got the absolute values first.
Absolute values first. And so what is the absolute value here? 7. And
2 minus 4 is -2.
we know that's -2, right?
So it's 2 over 7.
Times the absolute value of -2 is 2. The absolute value of 7 is 7.
And then
What am I?
minus sign is outside of the absolute value, so you just put minus, and then the absolute value of 3 is
3. Okay, so now what am I doing first? Andrew.
You multiply 7 and 2 sevens.
Good.
You cross cancel, so 7 and 7 equals 1, so it's 2 minus 3.
And then we end up with?
-1. Woo!
Okay, let's try the next one. Shh. Okay, let's try the next one. Go. Pause the recording. Before we get going, I want to remind you that when we have absolute value in an expression like this, you solve using order. You solve using order of operations, and we always do the activity inside of the absolute value before we take the absolute value. We don't take the absolute value till we get it down to one number. So what would we do first? Caitlin?
You first subtract 3 minus 7.
And what is that equal to?
-10.
Okay, so it's the absolute value of -10 minus, keep going.
-8 minus -9, which is -17.
Good.
And then minus
Shh. Times absolute value of -4. Okay, now what? Sydney?
You need to take the absolute values of each one of those.
Good.
So it'd be 10 minus 17 times 4. And then you have to multiply those.
And I get, now 10 minus 17 is -7 times 4. What am I doing wrong? Shh, raising a quiet hand, Jaden.
The order of operations states that multiplication comes before addition.
Multiplication before subtraction. So I'm multiplying -17 times 4. It's -68. And so my final answer is? Okay, I'm going to give you one more problem to work on at home. Shh. The absolute value of 5 minus 3 minus 18 over the absolute value of -5 times the absolute value of -5. Okay. So, yes. All right, do it now. Pause the recording, do it now. All right, Santi, what do I do first?
So first, the
Shh.
5 in the absolute value becomes 5.
That becomes a 5.
Then minus 18 is negative 15.
But don't forget your minus here. Tell me what I write.
And then 15 over 5.
What is it?
15.
First, we've got to do the action, which is negative 15 over absolute value of negative 5. So I don't care if you're doing it up here, but I want you to write it somewhere. I don't want you to lose on common errors. I mean on stuff because you just don't write it down and you lose something somewhere. Okay? And then over here, what does this become?
5.
By what? 5. Okay. So really, this, we could either make this become the absolute, since it's all in absolute value, I could do this, right? And that becomes what?
3.
Absolute value of 3.
What?
Or I could do it as 15 divided by 5. Take the absolute value, it's 15, and then divide. So either one is okay. Do you guys understand that? So let's do 15 over, we know that that's going to be a 3 times 5, and I have a 5 minus. So what am I doing? How about Noelia?
You would multiply
And that is? And my final answer? Good. Questions?
Can you just cross cancel? The 5?
Yeah, you could have.
Okay.
Once you're here, you could have done that.
And then the 15 minus 5. I mean,
No. Sorry, you can't because look. Oh yeah, you could have.
Yeah, I thought this.
It still would have worked
Okay.
because
In all cases?
yeah, because that's multiplication and division are at the same time. Okay,
I just thought maybe like
that's just a different form of division. All right, now let's go on to transforming formulas. Well, you want to do fractions or formulas? Let's go to our fractions because I'm here. All right. All right, so next let's do, like if I'm given 2/3 x plus 1/2 x equals 5/6 plus 2, x. Okay, what would we need to do to solve this? And I'm asking you to solve by clearing. I see a hand. Keenan. No. No, you're not solving by clearing. That's not the skill I taught you. Keenan.
we need to multiply the 2 fractions.
The what?
Multiply by the common denominator.
Which would be? 6. The least common denominator, we're going to multiply not just the fractions, all terms. So now I'm going to multiply this by 6. I'm going to multiply this by 6. I'm going to multiply this by 6 and this by 6. Now, if I were to write that out, it'd be 6 times 2/3 x plus 6 times 1/2 equals 6 times 5/6 plus 6 times 2x. Is that clear? But I don't need you to write that step. I can have you just go right here and just go from 3 goes into 6 how many times? 2 times. So I can just, I do a little slash here and I do 2. 2 times 2x is 4x. 2 goes into 6 3 times. 3 times 1x is plus, oh, look what I forgot here in x. 3x equals 6 goes into this once. 1 times 5 is 5. And then I end up with 12x. Okay? Now we are combining our like terms, Keenan. What am I going to get? 7x equals? Okay, next step. How about Harry? Good, subtracting 12x. And we get negative 5x equals 5. Dividing by negative 5, dividing by negative 5, x equals negative 1. One variable, one solution. One variable, one power, one solution. Okay, questions? Okay, let's try one with decimals. So if I have something like 16 and 3/10 minus 7 and 2/10 y equals negative 8 and 18/100, I want you to solve by clearing. So what might you do to solve this by clearing? Frank.
You could multiply everything by like 10.
Okay, if I multiply, so in this case, because I have 1 decimal, 2 decimals, I have to multiply by 2 powers of 10. That would be 2 zeros. So it would be 100. Do it, pause the recording, clear your decimal, and complete it. Go. Now let's do this. What do I do first? Shh. How about Julia? 2 places to the right. Whoops. 2 places to the right. I'm doing once, twice, so it'd be and minus 20y equals good. And now I'm subtracting 1630, subtracting 1630, negative 720y equals 8. It's 4. It's 4. Carry the 1. Oh, wait. 2. Yes, there we go. Okay, questions. Now we are dividing by negative 720. Divide by negative 720. And y is equal to? Go, Miriam. What? 3 4/10. Questions? So, are you guys clear on what I'm expecting about fractions and decimals? Clearing? Yes, question.
Do you want us to answer this in decimal form, or can we answer it as an improper fraction?
Well, if it's given to you in decimal form, it means I want to see it in decimal form. If it's given to you in fraction form, probably in mixed number or reduced improper. Okay? Reduced improper if it's a mixed number. All right, now let's do transforming formulas. The next section, isn't that 3-7? All right, so I gave you 2 problems. Number, is it 32? I really like 32. All right, so you are doing, and if you guys are talking over me, I will assume you don't want to do this. Okay, 1 over E plus F. And I want you to solve for F. Remember, we can either like write that, we can put the semicolon. Sorry, that's supposed to be a semicolon. Okay. All right, what do you think we do first? This is 32, page 144. Okay, what are we doing first? How about
Multiply both sides by e over 1.
Okay. I don't necessarily need to multiply both sides by e over 1. I need to get it out of the denominator. So, but if you have this and I'm multiplying both sides by e over 1?
Yeah, or just E.
No, because you have to think of this binomial. This is called a binomial, and we're going to get into that very soon, right when we come back. Binomials, that's like its own term. You can't separate it. We got to get the whole thing out of the denominator. How do I just get the denominator and make that be gone? I see a hand back there, Scott.
Multiply both sides by E plus F.
Right, just multiply both sides by e plus f. E plus f. Right? Now I can cross cancel it. It's out of the denominator. It's easier to work with. So now I have the quantity of e plus f equals times d plus 1. Now, we're stripping the left side away like it's an onion. You take the outer layer first. So Marcus, what am I going to do here?
Divide by D.
Now we divide by d. Trying to get closer to that. I'm doing inverse operations. It's actually like the opposite of GEMDOS. Inverse means opposite operations.
And then you're left with E plus F equals 1 over D. And you can subtract E, and now we are left with F is equal to 1 over D minus E. Yes?
How would you know that you have to multiply by D instead of like D plus the quantity?
I didn't multiply by D.
Oh.
Where are you looking at? Once I'm next to, okay, so let me just go back. Oops.
Oh, I think I see. Because there's the.
Okay, so once I'm here, right? I want you to solve for the F. And once I'm here, I'm multiplying by E plus F. Does that make sense? So now next to, it sets up this situation where we're next to. Next to means multiplication, since it's the whole quantity. If I had subtracted E plus F, then I wouldn't, it wouldn't just be next to. There would be a plus or a minus sign with it. Yes?
Could you have multiplied F on both sides to leave E in the denominator?
No. No. You may not do that. This is a binomial. It cannot separate. When it's in the denominator, you got to get it out and
Multiply by the whole binomial.
by the whole binomial. You can't take a piece of a binomial like that. Yes?
Use the distributive property
What?
with E plus F times G cubed, do the distributive property.
But why? Because then you're adding more to F. I don't want to distribute. So the question is, could I have distributed, I'm going to switch to yellow, could I have distributed here, right? Okay, if you do that, then you're adding another layer to F. Our goal is to get F alone. So why would I add that to F instead of right away get rid of the D? Does that make sense? Chloe?
So is it only a binomial when you have an addition or subtraction sign? Or
A binomial is made up of one or more terms, separated by plus or minus signs. So it's really only in this situation. So let's say I had another problem like this. Let's say I'm given D equals A plus B equals, X. And I want to solve for B. What would I do?
Divide by D on both sides.
Get rid of the D. We're not going to put the D closer to B. We're trying to peel it away like an onion. So the inverse operation, since this means multiplication, I'm going to do division.
And now I'm here, a plus b. I don't need the parentheses anymore. So what am I doing? Subtract by a, subtract by a.